Welcome to my class. Our topic for today is all about testing hypothesis. Our objectives are define and illustrate the null hypothesis, alternative hypothesis, and level of significance. Define and identify the rejection and non-rejection region and the critical value. And lastly, differentiate type 1 and type 2 errors in claims and decisions. Let us try this given example to deepen our knowledge with our topic. According to a survey, the average daily usage of social media worldwide of global internet users amounts to 142 minutes per day. Rizal conducts his own survey among his friends to find out if their time spent on social media is significantly higher than the global survey. There are two claims in the given problem. Claim A states the average daily usage of social media of his friends is the same as the global usage. And Claim B states the average daily usage of social media of his friends is higher than the global usage. If we're going to compare the two claims, the first one states the same and the second claim states higher than the global usage. Let us take this table showing Rizal's friend and their respective time spent on social media. This table shows the friend's name of Rizal and the minutes per day spent on social media. Let us try to answer the following questions later on. What statistical data is or are needed to prove which Rizal's claim is accepted or rejected? What is the average daily usage of social media of his friends? Compare it with the previous average usage. And lastly, which of the two claims could probably be true? To begin with, let us define hypothesis. A hypothesis is a proposed explanation, assertion, or assumption about a population parameter or about the distribution of a random variable. Remember, it's a proposed explanation, assertion, or assumption. Let's take the different examples of hypothesis. Twitter time spent on social media is significantly higher than a global survey. Is the proportion of senior male students' height significantly higher than that of senior high school? Do male and female grade 7 and grade 12 students differ in height on average? Let us observe the given example of a hypothesis. Let us now discuss what is hypothesis testing. It is a statistical method applied in making decisions using experimental data. This is basically testing an assumption that we make about population. There are types of hypothesis. The null hypothesis, which is an initial claim based on previous analysis, which the researcher tries to disprove, reject, or nullify. It is denoted by age sum O. The next one is the alternative hypothesis. It is the contrary to the null hypothesis, which shows that observations are the result of a real effect. It is denoted by age sum A. Let us now illustrate the null hypothesis and alternative hypothesis of a given problem. The school record claims that the mean score in math of the incoming grade 11 students is 81. The teacher wishes to find out if the claim is true. She tests if there is a significant difference between the batch's mean score and the mean score of the student in her class. Let mu be the population, and x bar be the mean score of the students in her class. So the given mean of the population is 81. Given the problem, let us now illustrate the null hypothesis and the alternative hypothesis. Using the option 1, the null hypothesis shows the mean score of the incoming grade 11 students is 81. In symbol, the mean is equal to 81. While the alternative hypothesis shows the mean score of the incoming grade 11 students is not 81. To illustrate, the mean of the population is not equal to 81. Let us try the option 2 of the given problem. We may state the null hypothesis of the given statement as the mean score of the incoming grade 11 students has no significant difference with the mean score of the student. Remember, the x bar or the mean be the mean score of the students in her class. So we may use in symbol mu is equal to x bar, where mu is the mean of the population and x bar is the mean of the sample. In the way, the alternative hypothesis can be written or stated as the mean score of the incoming grade 11 students has a significance difference with the mean score of the students. In symbol, mu is not equal to x bar, or the mean of the population is not equal to the mean of the sample. To be able to illustrate the null hypothesis and alternative hypothesis, let us go back again to the problem a while ago. Let us read again. According to a survey, the average daily usage of social media worldwide of global internet users amounts to 142 minutes per day. Rizal conducts his own survey among his friends to find out if their time spent on social media is significantly higher than the global survey. To apply the option 1, we will have the null hypothesis, which is the average global usage of social media is 142. The symbol, that is mu, is equal to 142. To be able to get the alternative hypothesis, it can be the average global usage of social media is not equal to 142. The symbol, that is mu, is not equal to 142. To apply option 2, we have the null hypothesis as the average global usage of social media is the same as the average usage of his friends. In symbol, we have mu is equal to x bar, or the mean of the population is equal to the mean of the sample. For its alternative hypothesis, we can have the average global usage of social media is not the same as the average usage of his friends. In symbol, we have mu is not equal to x bar, or the mean of the population is not equal to the mean of the sample. As an activity, you may answer your module on page 15, activity 1.1, entitled Null versus Alternative. State the null and alternative hypothesis of each statement. Let us now discuss the next topic, which is the level of significance. The level of significance is denoted by alpha, or Greek letter A. It refers to the degree of significance in which we accept or reject the null hypothesis. 100% accuracy is not acceptable. The significance level alpha is also the probability of making the wrong decision when the null hypothesis is true. Remember, most common levels of significant use are 1%, 5%, or 10%. To apply the level of significance, let us try to draw an answer to this given question. If Rizal used 0.10 level of significance, what are the chances that we'd have a wrong conclusion if the two values have no significant difference? To be able to answer that question, let us now discuss the next topic, which is two-tailed test versus one-tailed test. When the alternative hypothesis is two-sided, like null hypothesis is not equal to the alternative hypothesis, it is called two-tailed test. When the given statistic hypothesis assumes a less than or greater than value, it is called one-tailed test. To deepen our knowledge, let us try this. The school registrar in Casiglan Village Senior High School believes that the average number of enrollees this school year is not the same as the previous school year. Observe the given word which is being highlighted, not the same. To illustrate the null hypothesis, we have mu is equal to mu sum of O, where mu sum of O represents the sample mean. The alternative hypothesis illustrates mu is not equal to mu sub of O. To illustrate this given figure, we have this two-tailed test illustration. Remember, if the alternative hypothesis uses not equal sign, use a two-tailed test. However, if the school registrar believes that the average number of enrollees this school year is less than the previous school year, then you will have the null hypothesis, which is mu is equal to mu sub of O, and its alternative hypothesis, which is mu is less than mu sub of O. Observe the word which is highlighted in red font, less than. To illustrate this in a given figure, we're going to observe that the tail which is shaded is on its left side. Use the left tail when the alternative hypothesis contains the symbol less than. On the other hand, if the school registrar believes that the average number of enrollees this school year is greater than the previous school year, then you will have the null hypothesis, which is mu is equal to mu sub of O, and its alternative hypothesis, which is mu is greater than mu sub of O. To illustrate this into figure, we're going to observe that the given tail is now on its right side. Remember, use the right tailed when the alternative hypothesis contains the symbol greater than. Okay class, now let us go back to the claims of Rizal. What do you think should be the type of test in these following claims? Claim A states the average daily usage of social media of his friends is the same as the global usage. Observe the word same. In this case, we're going to use two-tailed test. For claim B, the average daily usage of social media of his friends is higher than the global usage. Observe the word higher than. In this case, we're going to use one-tailed test. As an activity, you may answer your module on page 16, activity 1.2, entitled The Tale of Tales. The direction states, determine if one-tailed test or two-tailed test fits the given alternative hypothesis. Good luck and enjoy answering. Now, let us move on to our next topic, which is all about rejection region. We're going to use the t-distribution curve to be able to show the different parts of the rejection region. We have the shaded part, which is the rejection region or the critical region. The unshaded part, which is the non-rejection or the acceptance region, and the line that divides these two given regions is what we call critical value. Now, let us go back to the claim of Rizal using the given data on the table on our right side. He assumed that the average online usage of his friends is higher than as the global usage. To be able to solve this, let us now find the given. The given are the mean of the population is equal to 142 and the mean of the sample that comes from the data on the table on our right side is 152, the standard deviation which is 19.855 which is solved using this formula, and our sample is 10. Applying the formula of t-value, we have the mean of the sample minus the mean of the population divided by the quotient of the standard deviation and the square of the sample. Applying this formula, let us substitute the given. We have 152 minus 142 divided by 19.855 divided by the square of 10. Using our calculator, we may arrive to t is equal to 10 divided by 6.2787. And our final answer is 1.593. Now, let us use the t-table of values to determine the critical value. Using the given 5% level of significance. First, let us get the degree of freedom. By using the formula, degree of freedom is equal to n minus 1, where n is our number of samples, which is 10. 10 minus 1 is equal to 9. 9 will be used as our reference on our given t-table. And 0.05 here is our level of significance. Here, we're going to observe that our critical value falls on 1.8 833. By using the illustration, we're going to observe here is the critical value and here is our computed value which falls under the non-rejection region. Thus, the decision will be fail to reject the null hypothesis. Now, what if we want to try the claim of Rizal that the global usage is also the same as the average usage of his friends in terms of using social media with 10% level of significance? Remember, the t-value that we have solved a while ago is t is equal to 1.593. And by means of t-table, we're going to get the critical value. First, let us identify the given degree of freedom, which is 9, and by its level of significance, which is 10, which falls under 0.05. The critical value is 2.262. Since the critical value is 2.262, by means of illustration, we're going to observe the left and right level of significance, which is 0.05, and its given critical value, which is negative 2.262 and positive 2.262. And our given t-value, which is 1.593, which falls on the unshaded region. This means the decision is fail to reject the null hypothesis. Now, let us go back to the two claims of Rizal. Claim A states that the average online usage of his friends is the same as the global usage. If you're going to remember, this claim shows a two-tailed solution, while Claim B, which states the average online usage of his friends is higher than the global usage, shows a one-tailed solution. Arriving to the given t-value of given two claims, it all falls under non-rejection region. Thus, the decision in these two claims falls under fail to reject the null hypothesis. Now, let us try to sketch the rejection region using the given critical values and the computed t-value. Let us try this. Sketch the rejection region of the test hypothesis with critical values of positive negative 1.753 and determine if the computed t-value of negative 1.52 lies in what region. Let us observe the given positive negative 1.753. This given illustrates that we're going to use a two-tailed. And our given computed value, which we're going to use as our determinants in what region the given value falls, which is negative 1.52. First, let us draw the t-distribution curve. And then, let us locate the critical values, which is positive negative 1.753. And locate now our t-values, which is negative 1.52. Here, we're going to observe that negative 1.52 falls on the unshaded region. Therefore, this kind of illustration shows that we fail to reject the null hypothesis. As an activity, you may answer your module on page 16, activity 1.3, entitled, Are you in or out? Given direction, illustrate the rejection region given the critical value and identify if the t-values lie in the non-rejection region or rejection region. Now, let's have our last topic, which is all about type 1 and type 2 error. Rejecting the null hypothesis when it is true is called a type 1 error, with probability denoted by alpha. In hypothesis testing, the normal curve that shows the critical region is called the alpha region. While accepting the null hypothesis when it is false is called type 2 error, with probability denoted by beta. In hypothesis testing, the normal curve that shows the acceptance region is called the beta region. Now let us analyze the possibilities of Rizal's conclusion. Let us identify if it's a type 1 error, type 2 error, or correct decision. If Rizal finds out that his null hypothesis is, first, true, and he fails to reject it. He fails to reject it means he accepts it. True and accepted commits correct decision. True and rejected, or he rejects it, he commits type 1 error. Third, false, and he fails to reject it or accepted it, then he commits type 2 error. Lastly, false, and he rejects it, he commits correct decision. In real life, as a young adult, we can express type 1 and type 2 error similar to the situation of asking permission to our parents. For example, when you give the true information of where are you going, your parents tend not to agree or permits you to go out. While there is a time that when you give false information, your parents tends to agree with you and let you go out. But then, that is also an error. So be careful of giving information to your parents. Now, let us apply type 1 and type 2 error in the following situation. Brian is starting his food cart business and is choosing cities where he will run his business. He wants to survey residents and test at 5% level significance whether or not the demand is high enough to support his business before he applies for the necessary permit to operate in the selected city. He will only choose a city if there is a strong evidence that the demand there is high enough. We can state the null hypothesis for this test as the demand is high enough. What would be the consequence of a type 1 error in this setting? Given the following statement, he doesn't choose a city where demand is actually high enough. He chooses a city where demand is actually high enough. He chooses a city where demand isn't actually high enough. Remember, our null hypothesis is the demand is high enough. And the type 1 error shows that the given null hypothesis is true but not accepted. Therefore, the given statement that shows a type 1 error in this different statement is correct. Number 1, he doesn't choose a city where demand is actually high enough. Using the same situation, what would be the consequence of a type 2 error in this setting? He doesn't choose a city where demand is actually high enough. He chooses a city where demand is actually high enough. He chooses a city where demand isn't actually high enough. Remember, our null hypothesis is the demand is high enough. And type 2 error states that you tend to accept the null hypothesis if it is false. Therefore, the given setting that express type 2 error is the third one. He chooses a city where demand isn't actually high enough. As an activity, you may answer your module on page 16, activity number 1.4, entitled Type 1 or Type 2. The direction states, check the box that corresponds to your answer. Now, let's have the summary of our lessons for today. The first topic is all about hypothesis. It's a proposed explanation, assertion, or assumption about the population parameter. We have two types of hypothesis, the null hypothesis and the alternative hypothesis. Null hypothesis shows a claim based on previous analysis which the researcher tries to disprove, reject, or nullify, while the alternative hypothesis is the contrary to the null hypothesis. The second topic is all about the one-tailed and two-tailed test. When the given statistic hypothesis assumes a less than or greater than value, it is called one-tailed. And when the alternative hypothesis is two-sided, it is called two-tailed test. The next lesson is all about the rejection region. Rejection region consists of the following parts: the critical value, the non-rejection region or acceptance region, and the critical region or the rejection region. And our last topic is all about the type of errors. We have two kinds of errors. The first one is type 1 error. Type 1 error refers when the null hypothesis is true but rejected. And type 2 errors exist when the given null hypothesis is false but accepted. And with that, that's all for today. Thank you for listening. Aim high, senior high.